Hi there. Good to be here. Okay, so let's get started. You can see the link here, bit.ly/security-slides. This is a PDF of this entire presentation. I am going to have a lot of links. We are going to cover a lot of topics, and I want to make sure that you have what you need to look up all the topics that I'm going to mention. So let's get started. This is me on Twitter. So hello from Austin, Texas, in the U.S. A little bit about me. I most recently released a open source framework called HashTuner. It's pretty small. It allows to password hashing algorithms, starting with Argon to ID. We're going to touch on that a little bit later. And I also helped upgrade the oauth 2 bundle from Tricoder to Symfony 5 in the 3.0 release, and we're going to briefly look at that too. Okay, so again, here are the slides. If you want them, get them. So first, let's look at software. It's obviously everywhere. If you look at banking, finance, travel, entertainment, communications, home automation, alarm systems, these areas, including military and aerospace, right? There is software everywhere. So obviously you could ask yourself what could possibly go wrong, right? So you have this is an example of a Tesla car. Tesla is doing really cool things with self-driving cars. So yeah, what could possibly go wrong? This could happen, right? But hackers have been having fun for some time with kind of remotely driving cars who have too much intelligence baked into them and poor security. And they did it again the next year. So a lot of these things, have been happening. They continue to happen. When it comes to web applications, let's look at your business, right? Your business data hopefully lives in your own kind of private cloud network. It's not exposed to the outside world. And inside of your private network, you may have a CRM or an inventory management application that your employees might interact with through a VPN. And then to the outside world, you could expose your website, your service station, your API, through ports 80 and 443, right? And so on the right side of the screen, that's kind of where you start exposing your data to the outside world. So attackers are going to do two things. They're going to try to go after your business data by compromising your employees, or they're also going to try to get in through your web applications. And they're going to try to hack your web applications to get at your business data, right? And so this is kind of why we're going to focus on that today, this portion of the graph. This is kind of where, web application security comes in. So obviously, there are a lot of business risks, right? I'm not going to, do this, but, these are pretty obvious risks. So and there have been a number of security breaches. I have a lot of links here. I'm not going to spend too much time on them, but, it's always good to keep in mind kind of, the past breaches that have happened now. You had Yahoo, the OPM office, Equifax. These are all very high profile security breaches. With this said, every day thousands of web applications get compromised all the time. And why is that? Well, the thing is, there are millions of them. There are millions of web applications and websites. It's very easy for vulnerabilities. If you tail your logs, you will see a lot of breaking attempts. Most often, web applications expose sensitive information. They interact sensitive information, so they are very valuable. They tend to have large attack surface, and we're going to touch a little bit on that toward the end. And also denial of service. I'm not going to cover that. I have a separate talk on that, but I'm not going to cover that here. So we're going to look at strategies to improve our security posture. And first and foremost, the thing that matters the most out of everything is to educate ourselves, educate humans. We as software engineers need to become better at writing software that is more secure. That's the first line of defense, right? This is where you want to try to catch all vulnerabilities, right? But if that fails, code reviews are a thing. We have peers, we have other human beings who can also help us catch security issues, right? Just like they can help us catch. And then this is kind of where, as a further fallback, this is kind of where your continuous integration pipeline kind of comes in. You could have automated code scanning, dependencies, vulnerabilities check. So dependencies, vulnerabilities, these are vulnerabilities in code written by third party. So, your application uses frameworks and third-party libraries. And so we're going to show you tools that allow you to aware of vulnerabilities in those. Then you have automated penetration tests as well. Then you can try to put a web application firewall. And then when all else fails, you hope that you have sufficient logging in place to figure out what happened, right? So today we're going to look at these topics in bold on your screen right now. So I like to draw a red line here because I really want to call out that you want to try to catch as many of the vulnerabilities above the red line instead of below the red line, right? The further below you catch vulnerabilities, the more costly it becomes to fix them. So the first thing we're going to look at is to educate humans. So OWASP is a phenomenal resource. I highly recommend of all web developers, web application engineers, to really spend a lot of time on the OWASP site, and we're going to keep referencing OWASP throughout this presentation. And what I like about their philosophy is they approach application security as a people, process, and technology, right? Security is not just it's not just a technology thing, right? People and process a lot. So every year they publish, roughly every year, they publish a top 10 vulnerabilities. Here's a link to it. You should always check it out. We're going to touch on some of these top 10 vulnerabilities. These are the things that I come across the most in the many applications that I've worked with. Adding into those, now we're going to look at tooling, right? Because educating humans is one aspect of it. Thankfully, there are tools that can kind of help us improve our security posture. So one key aspect of tooling is having a continuous integration framework. You are likely already using a CI framework today, right? It could be GitHub Actions, Circle CI. I use it on my HashTuner project. Travis CI, many open source projects use Travis as well. They use it on that oauth 2 bundle project that I helped. You got Jenkins, TeamCity by JetBrains. There are a lot of them, right? These are the three that I've used before. I'm sure they're all fine. So, and when we look at security tools, we're going to look at three types of tools. One is security static code analysis from a continuous integration standpoint. Another one are those dependency vulnerability checks. And then we're going to look also at automated penetration tests. So I'm going to show you kind of one way you could fit it all together. It's not the way, it's to do it, right? Imagine that you push a code change to your Git repository. That's going to get fed into your CI pipeline, where hopefully you're already running some unit tests, maybe some integration tests, and then comes in static code analysis. So there are tools that will do code analysis from a quality standpoint, but also from a security standpoint, right? And so we're going to focus on security. So this is kind of where you could inject security, and also your dependency vulnerability checks, fit pretty well in your CI pipeline. Then once you pass everything through your pipeline, you might automatically deploy to a server, right? Once you have your application sitting on a server, you have to have automated penetration testing tools constantly hitting the server. Hopefully before your application gets in production, because once your application is in production, you get automated penetration tests for free, because hackers are always trying to hack into your production application, right? So you definitely want to catch any issues in your development and staging environments before you get to production. Okay, so let's look at automated code scanning, also known as static analysis. These are vulnerabilities in your code, not third-party code, your code. So the OWASP project has a list of source code analysis tools. This is a link to it. I've been using at my work SonarQube. It works great. It's a framework that works with nearly just about all languages. There's a plugin for every language out there. And so we use the Sonar PHP plugin with SonarQube, and it's been working. But there's also other frameworks like ProcPilot, PHP-CS, Security Audit. So these are options that you can look at, which are free. They're open source to do code scanning. If you work in full stack applications, you might be doing some JavaScript code. So there's also a Sonar.js plugin, right? And here in this presentation, I'm trying to, for the most part, only plug open source, free open source technologies. Obviously, there are a lot of really good commercial solutions out there. I'm just kind of trying to not be biased toward one or the other. So, so dependencies, vulnerabilities checks. So now we're going to look at finding vulnerabilities in third-party code. The OWASP project has built a tool called the OWASP dependency check, and it supports multiple languages, including PHP. But for PHP, there's kind of a better way to look at this. One is the Rove security advisories. This is a great, anytime you add a new package to your composer, this will tell you if you have a vulnerability with the thing that you're adding to it. And then Friends of PHP has a security advisories framework, which will look at your entire composer.log file, and it will find vulnerabilities in there as well, right? So you could use these two concurrently. You might start out with the Friends of PHP framework to find all the existing vulnerabilities, and then going forward, when you write new software, you just keep using the Rove package. Okay, and then in JavaScript, again, you might be doing some JavaScript code. There's a framework called Retire.js, which again tries to find vulnerabilities in third-party JavaScript libraries. Okay. Now let's look at automated penetration tests. So OWASP has created a project called OWTF, which does not sound for what you might think it stands for. It means Offensive Web Testing Framework. They've also made it called the Z-Attack Proxy. So these are fine tools. There's one that's famous, obviously, Metasploit has been around for a long time. It can test a lot more than web applications, but it does have a very comprehensive suite of testing for web applications. Okay, so now let's look at web application firewalls. So I always try to caution people with web application firewalls. So typically, they're a reverse proxy that you put in front of the web server. It could also be an HTTP daemon plugin, that you run. The biggest I've run into with those are false positives. It's really a big problem, especially when you have user-generated content. You definitely need to do them properly and do a lot of testing. But there are a number of them out there, right? You have Mod Security, that's kind of the most famous one. You have the REST WAF, ShadowD. So these are all fine solutions. But again, make sure you test them a lot and super careful with them. Yeah. I personally don't recommend using a web application firewall unless you're absolutely sure of what you're doing. Okay. So this kind of section, I kind of wanted to give you awareness of all of these tools so you can start adding them into your application today, in your processes today, so that you will at least start catching some issues. So now let's go back to educating humans. I'm going to try to guide us through understanding vulnerabilities. And so we're going to look at two types of vulnerabilities. One, what I call low level, another one I call application vulnerabilities. Let's start with low level. So we're going to look at injection of vulnerabilities, SQL and NoSQL injections, cross-site scripting, and then we'll also look at CSRF. We're probably not going to spend much time on XSS and CSRF, but yeah, I have a lot of links there. So let's look at the SQL injection. I'm sure you've all seen this comic that's been around for a long time. It's the old Bobby Tables comic. So an SQL injection can have a devastating impact. And you know, the vector is pretty simple. You have an SQL string in which you're inserting a variable. That variable can be compromised and contain a fragment, right? So this is a way to, you know, create a vulnerable string, right? You're injecting a variable straight into the SQL. So user ID could be a nefarious string. So the key mitigation to it is to use prepared statements with name parameter binding. Input sanitation helps, but it'll be brittle and it's not going to be that useful. Prepared statements are really what you want to use, regardless of language that you work with, regardless of database that you work with. All databases support prepared statements. And it's pretty simple. It kind of looks like this, right? Select from users where ID equals :ID. So now :ID becomes a reference that you can bind later on. So here I have a link to a cheat sheet on how to do it in different languages. So the prepared statement kind of looks like this, right? You call a bind parameter function or method that will bind your variable to the ID marker that's here with the colon, and that's it. That's pretty simple, right? So here's a way to do it with PDO in PHP. So again, really simple, completely worth doing, and to my knowledge, if you use prepared statements as they are intended, you should not get injected. So now a lot of us do use, it is possible to get SQL injected through ORMs if you're not careful. So a while back, there was a CVE that was published for an HQL injection. Since Hibernate query language is the same to Doctrine ORM, it is conceivable that it could also be extended to Doctrine. Have not verified that. But here I have a link to testing for ORM injection vulnerabilities. So you should always kind of keep it in mind. By and large, if you use an ORM as it is intended, you should be okay. But I'm going to show you an example where you can get in trouble. I'm going to show you examples on two prevalent types of ORMs. You have your active record patterns such as Laravel and Eloquent, and then you have data mapper pattern ORMs such as Doctrine ORM. So here's where you could get in trouble with a data mapper ORM. If you're doing something like this, you're building a DQL where you're referencing an object, ride R, where r.destination.id equals, and then you append a variable to the, instead of doing a name parameter binding in your DQL as it's intended to, you're just doing what is supposed to be an integer to a string. Well, you could get in trouble, right? Obviously, a better way to do it is just to use the OR as it is intended, right? With named parameter binding into the string, and preferably referencing an object, instead of referencing just the ID of a destination object, right? So on the active records side of things, if you look at Eloquent, they have those raw methods where you could get in trouble with something like this, right? User where raw equals age greater than, and then you're just inserting your age parameter that came from the request straight into a string here, right? Conceivably, this string could get compromised to alter the SQL that gets generated at a lower level, right? You want to stick to the constructs that Eloquent gives you, right? Using the where method, and then you pass the comparison argument as a separate string in the dedicated field, and then you pass the target age as its own parameter. So from that point on, Eloquent knows exactly what to do, right? What's your argument, and then what's your SQL constructs. Okay. So yeah, like I said, ORMs give you an expressive vocabulary. They make the safe way very convenient, but it is still possible to get in trouble if you don't use them as they were intended, right? That's the basic thing. If you're using NoSQL databases, yes, it is still possible to get injected. I have a link here on how to test for that, so you should check it out. I have some articles. But an example here is kind of an example of querying Node, where you have a query like this, and instead of this less than 0 on the right, now you just go less than, and then you put user input there. Well, if that user input happens to be a string which looks like this, well, that string is going to cause 100% CPU for 10 seconds, so it could kill your server, right? So you have to be careful. So here I have an article on kind of preventing these issues. They recommend to cast arguments to string. So yeah, I'm not going to spend too much time on cross-site scripting. I have a link to a number of resources. So the biggest thing is you don't want to put untrusted data in script block, HTML comments, HTML attribute names, HTML tag names, CSS blocks, because there are no escaping or encoding mechanisms that are reliable for those. If you output JSON, make sure your content type is actually JSON and not HTML. That happens a lot, because then somebody can put a script tag in the JSON output, and then if you view your API in a browser, that script is going to execute, which is not great, right? So make sure that you use the proper MIME type. So inside your HTML document, make sure you escape everything. If you HTML entity escape if it's a JSON blob you want to put in there, you can use Yahoo's serialized JavaScript. And then if it's a URL fragment, make sure that you URL escape it. So good news is, whether you're using Symfony or Laravel, output escaping in the HTML is already being handled. So hold on a second. Sorry about that. I'm back. So that's for rendering. When it comes to saving data, you got to be careful. You want to avoid double encoding things. So I prefer to strip things instead of escaping or encoding. Your focus should be on deleting things that should not be there, such as HTML tags. Try to use proper data types in your data store, right? You don't want to store numbers as strings, right? If they're numbers, store them as numbers, and that's basically it. All right, so CSRF, I'm going to skip over that. The biggest thing is to just make sure you look at your framework, your framework's documentation on CSRF. Okay, so here's Symfony Laravel. Okay, so now let's look at application vulnerabilities. So we're going to look at 3 topics. User authentication, OAuth security, and then access control and multi-tenancy. So let's dive into user authentication. Within user authentication, we're going to look at a bunch of topics. I have a link to a cheat sheet here on the OWASP site, so you should definitely read this material. But I'm going to give you a lot of perspectives here. So we're going to look at failure messaging, failure handling, multi-factor authentication, account recovery, password policies, password hashing, password transport, session duration, and reauthentication, and then what happens when you have a compromised account. So failure messaging, you don't want to give too much intelligence. So you keep, if somebody enters the wrong password, wrong username, you don't want to tell them, hey, you entered the right username, but the password is not quite correct. Please try again. You don't want to give them this type of intelligence, right? So you want to avoid saying wrong password, meaning user ID is correct and then the password is wrong, right? You don't want to say wrong user ID, because now you're saying, hey, this user does not exist, right? Again, giving them too much information. Account disabled, that's also bad. User not active, right? These are all pieces of intelligence that you are giving hackers as to what your system has. So just keep it vague, such as login failed, invalid user ID or password. That's one way to say it. As long as it's vague, it's good. So the thing about failure handling is, you could have a lot of brute force attempts. You could limit failures by IP address, but that could get you in trouble if you have multiple users on the same network, where one user does 5 failures in a row, then you block the IP, and then everybody on that network is being blocked. It's not great. CAPTCHA, you could try to put CAPTCHA on your login form, but that's a good way to alienate your users very quickly, right? But you should at least ask yourself this question, should we mitigate brute force attempts, and how can we do this? So definitely try to log all failures. What was the attempted user ID, any kind of timestamp, IP address. You might also consider logging successes if an account gets compromised and somebody's doing bad things with that account. All right, so multi-factor authentication. I have a link here on Wikipedia that kind of explains what that's going to do. SMS phone-based verification, you got to be careful with it, because those phones do get stolen, and then also carrier accounts get hijacked as well, right? I have a link to what happens with SIM cloning your phones, right? The other thing is, close your website and an SMS verification message, because if the phone gets stolen, you don't want to give the finder awareness that they go to this website and they authenticate on there, right? So now account recovery. Security questions, I'm not a fan of them, because really this should be treated just like passwords. You should store them just like you would passwords, with the same amount of security using hashing, and we're going to touch on that a little bit later. However, for different service models, hashing becomes not that practical, and so a lot of companies just implement this very poorly, and there's a lot of very sensitive information out there. So I have a link to an article here that you should read that kind of touches on a lot of these topics. But a more typical way to do account recovery is with an email with a one-time reset token. Make sure that the reset token does not linger in the URL. Definitely redirect it. The problem is, anything that lives in a URL, if somebody is on your site and they have the reset token in the URL, if they click off of your page, if you have a link in your footer to some other website, then the URL is going to show up in the HTTP refer header. So now you're starting to leak. Try to, as soon as you've consumed the token, try to at least just kind of quickly redirect right away without the token in the URL. Definitely try to expire that token quickly, not more than 24 hours. But accounts do get compromised. So another way to do account recovery is one-time code over SMS. But again, phones do get stolen, so just be careful. Upon recovery, definitely invalidate all existing sessions. All right, so now let's look at password policies. So one of the first things you should try to do is to forbid users from entering a password, which is from lists of known passwords. I have a link here to a small list to a big list of known password by Daniel Miessler. You should try to forbid user from entering one of their last 5 passwords. The length of the password be 10 characters or more. You should not have the username in the password, and you should try to use at least 3 of the 4 available character types, such as lowercase, uppercase, numbers, and symbols. You might consider making users change passwords every 3 months. However, as a practice, this is being added. Windows 10 server is dropping password expiry. So something to keep in mind. Now let's look at password hashing. So obviously, you never store the password in clear text, and this is kind of where password hashing comes in. You can assume that your database has been stolen, and if your database is stolen, can the hacker can the hacker get access to your user's passwords? Right? You want the answer to be no. Don't use one-pass hashing algorithms like MD5 and all the SHA variants. These are hashing algorithms that are not designed to be password hashing algorithms. They are not secure enough. You want to try to use an industry standard hashing framework, which has any number of those features, including it's multi-pass, puts strain on the CPU and puts strain on memory as well. It has a unique salt baked into the hash. That's very important. So bcrypt is what's prevalent today. It's still okay. People are starting to build rigs dedicated to bcrypt cracking with like custom ASICs. If you have good password policies, though, bcrypt is still very strong. With this said, Argon 2 and all of its variants like Argon 2i, Argon 2d, Argon 2id are starting to become the new standard, and Argon 2 won the password hashing competition in 2015, and so you can read more about this in an article here by David Whitlock. So the thing about Argon 2 is good, but you have to tune it very properly, and there are threads, memory, and CPU, and in PHP you can really only use tune memory and CPU. So I've created a little PHP application that you can use as a FAR file, but it's also got a full-blown API that you can integrate in any of your projects. It's called Hash Tuner, and it's built right now to help you tune Argon 2id, but you can extend this framework to tune any kind of hashes past and future. I highly recommend reading this article by Nicholas Grekus, who spoke earlier about password hashing in Symfony. Here's an article about password hashing in Laravel. And here's another article by Nicholas Grekus on hashing. He touches on many topics, but one of them is kind of the challenges of having secure hashes, getting taken down by a denial of service attack. And he's kind of showing a little bit some resiliency and scalability patterns, but also kind of shows the challenges that we're going to keep facing on this front. So I think it's very worth reading. Highly recommend it. So for transport, definitely use TLS for everything. Let's Encrypt gets you, free TLS certificates. So it's a good idea to, put encryption. If you don't want to put encryption everywhere, definitely do put encryption, login and registration and password and all this stuff. Let's look at session length and reauthentication. So you want to try to keep sessions as short as tolerable for your application. So what you could do is have a shorter lived session for more sensitive areas. So here's an example. You could stay logged in forever to browse inventory and add item cart, right? So that's like one session. That's like a long-lived session. But when it comes to doing anything that is transactional, such as finalizing the purchase, then you could make the user re-enter the password, and then they're only logged in for 5 minutes, for example, right? That's one way to kind of balance security with usability. So if an account gets compromised, you could have a variable event log where, kind of in a separate data store that you can scale independently with separate credentials, and you could try to gather as much forensic evidence as practical on all activity throughout your system, such as user ID, IP address, timestamp, and the operation being performed. However, do keep in mind that the GDPR Act forces you to have accountability with your users, and if a user asks to get them, you need to be able to do that, right? Including everything that you've logged to your event log. So kind of, be careful there. All right, so that was for password. Here's a picture of Archer, my dog. Okay, so we're gonna go briefly through OAuth security. So OAuth, to understand OAuth, there are two things that you need to understand. One is authentication. Authentication, and then the other thing is authorization. What am I allowed to do? So when the OAuth came out, it really focuses on authorization. It doesn't care too much about authentication. So this is kind of where OpenID Connect, also known as OIDC, came out to kind of give you a specialization of OAuth 2 and to really focus on authentication. And it's widely used by, social media, web apps, phone apps. They pretty much all use authentication. Important because, we're all building web applications, and at some point we'd like to create a phone app which interacts through an API, which interacts with an API for our web application. And that's at that point that we may be interested in adding OpenID Connect capability into our application. And that's kind of why I like to OIDC. So OIDC supports 4 grant types. Implicit used to be one, but it's being phased out, and now people want to use a different flavor of implicit, which uses auth code plus PKCE. I have a link to it. You can read about it later on. So I have an article here about these topics by Keith Casey. It's a great article. So the implicit flow kind of at a high level, right? Super high level, kind of looks like this. Sorry, so that's this implicit flow with auth code and PKCE is going to be very with most web applications. So page applications are going to want to use that, phone apps as well. And the key here is that the user's login and password is never persisted on the client. So the user opens the app, which after a few hands to login, grant HTML page from the OIDC provider, which after some handshakes returns an ID token back to the app. And then the app can send this ID token to your API, and then your API will validate your ID token using a number of shared secrets that it shares with the provider. So the key here is that what pink is your code. So from a security standpoint, make sure you use TLS. If you use an OIDC server, make sure you register the valid redirect URLs. Have a link here to proper token validation. If you're using a JWT token, make sure you don't include sensitive information in your JWT token. All right, assume that it can be leaked. But if you do store it as a cookie, try to make it HTTP only and secure. Definitely try to use OIDC client libraries as well as servers, right? Avoid doing OAuth 2 or OIDC yourself, and definitely try to use libraries. So speaking of libraries and frameworks, I really helped OAuth 2 bundle project from the Tricoder folks to upgrade to Symfony 4 and 5. So as of February 2020, version 3.0, now they're at version 3.1 or 3.2 already. But as of 3.0, now we have Symfony 4 and 5 support So you might consider that. Under the hood, they leverage the PHP League package. So if you want to add OAuth to OIDC server capabilities into your application, you could do your own integration with the OAuth 2 framework from the PHP League. But if you use the OAuth 2 bundle, it's an easier integration, right? It's less work for you to do because it's a built-in integration with Symfony. But if you're not with Symfony, you could use that to use the PHP League package in your Laravel application, for example. So I try to help the friends of Symfony folks. They seem to not be maintaining actively. So I made 2 pull requests, grade their bundle to Symfony 5. I haven't heard back yet. So if you know these folks, let me know. I'm happy to work with them. But yeah, I also have a link to my fork, so you can test it if you want to play with it. I also accept pull requests to my fork if you want. But otherwise, the Tricoder OAuth 2 bundle should be a good good way to go. All right. So if you're using a client, if you want to OID client, you have Passport.js, and then you have identity model for kind of client middleware side of things. All right. So that was OAuth. So now let's look at resource access and multi-tenancy. So there is a category of vulnerabilities which I've come across a lot, and OWASP classifies that as broken access control. Quite simply, imagine that in my application, I have a report with an ID and in the URL. I am the only person who is supposed to be able to see the report, right? But assuming this is my report and I see an integer in the URL and I'm like, I wonder what happens if I change the number, if I increment it, am I going to see somebody else's report, right? This is something that gets very easily overlooked, and it's always very important to always be mindful of who is supposed to be able to see this resource. There's business logic in our application, right? There's no framework that allows you to do that. You really got to think through it, right? Some folks might say, oh, but you could use unique user ID, UUIDs. Now, sure, UUIDs are non-guessable, but again, like I said earlier with the HTTP refer, right? When you click around an application, those UUIDs eventually get leaked. It's just security through obscurity is just not a good way to go, right? Make sure that you accurately control all the access controls in your application. So, all right. And it's also bad when one user of your application sees another user's information. But if you're working in a SaaS application where you have multiple companies, imagine how devastating it is for a user to see another user's information from another company. So, that's kind of why this is very important to keep in mind. I see this a lot. I just want to make sure that you're aware of it. All right. Last topic, architectural considerations. Let's stores. Whether it's SQL or NoSQL, no data store have a public IP address. Okay. If you put a data store on a network, you should not be able to access it from outside of the network. So it should be on a private network with a web server. Only the web server should be able to connect to your database. Definitely, if your data store supports passwords or encryption keys, use them. But the biggest thing is if you don't put them on a public network, then they're not accessible. That's definitely the best first layer of security. I have an article here that, for some reason, people think that it's okay to put MongoDB databases on an open network. Like I would never put, a MySQL database on a publicly open network. Would never do that. Even if I put a server, even if I set a password on my database, I still would not want that database to sit on an open network. And it's the same thing with MongoDBs, but people still, for some reason, do it with MongoDB. So it's not MongoDB's fault. It's really just something you don't do, right? And yet people do it. So try also to keep in mind the least privilege principle. You might only allow select update operations in your application, right? If you have a root user, you can do a lot more destructive things. So really, on a day-to-day basis, your application should only be doing select, insert, and updates. You might also be doing some deletes, but are you actually deleting records, or are you doing like more soft deletes, right? Kind of marking a flag on a record. And also, if you have to delete records, should these operations happen in an offline process that is separate from your web application? So in the offline process, which could have its own dedicated credentials, So the other thing is, if you have a web application, it's a good idea to create multiple users to mitigate the impact of hacks. So you could have a read user with its own username and password that is only allowed to do select, and then you could have a write user with its username and password, which can only do write operations. And so if compromises you through one of those two users, they're still going to hurt you, but they might not be able to hurt you as much as they otherwise would. So now we'll look at kind of network and system design. So anytime you put a machine on the internet, right, you have the machine's operating system, on top of which you have daemons, could be SSH, Nginx, MongoDB, MySQL. Then you could have application frameworks that interact with those daemons, right? You have a web framework like Node, Symfony, Rails, Django. That framework could have a bunch of plugins that are tagged into it, right? And then on top of it all, finally, you have our code. So anytime you put a machine on a network, attackers are going to, one of the first things they're going to try to do is do brute force low-level hacks, using credentials or buffer overflow attacks, right, against any daemon that's running on any port, right? They're going to try to do a buffer overflow, or they're going to brute force credentials. Once they're able to hack into one of your daemons, they might be able to compromise the operating system, and then at which point they can very easily compromise your application on a full stack basis, right? So anytime you put a machine on the internet, that's going to happen. Now, if another thing that can happen is they might start coming into your application through OWASP hacks, right, at the higher level of your applications. And then once they do compromise it, then they might be able to go the other way and infect your daemons and your operating system as well. So I kind of want to, one of the main things that you want to keep in mind is you want to reduce cross-contamination and make sure that you try to isolate each service onto its own machine. A machine can be a contaminant hardware. You want to avoid running unnecessary services. Try to keep each service securely patched. Try to have strict network restrictions on cross-machine communications. And nothing should connect to your data store except your web server. And nothing should connect to your web server beside your load balancer. And I'm going to show you a little bit what that could mean. So I'm going to show you first an example of a widely insecure setup, right? You have your data store on the open internet. You have a bunch of web servers on the open internet. And then you put your load balancer, and then you add one more data store, a bunch of web servers, and everything is on the open internet, right? So then attackers are going to look at your load balancer and say, cool load balancer, bro. And they're going to go around it, and they're going to try to hack every single one of your machines that sits on your load balancer. And they're going to hack one of those machines on a full stack basis, from low level to high level, right? So a more secure setup could look like this, right? You kind of have something like this. Boom. You have your firewall between your data store and your web server so that it can only communicate over a very specific port. You may have a firewall between all of these layers and your load balancer. And then if you want to manage these services, you could have a VPN networks, such that DevOps can kind of go in and manage all of the boxes. So the key here is attackers can only, architecture such as this, attackers can only attack you through OWASP vectors instead of doing kind of full stack vectors. So that's good to keep in mind. All right, so now let's look at securing credentials. Remember, Git never forgets. Anything that you check into Git is there forever. So check credentials to your Git repo. whether it's data store, AWS keys, your third-party API credentials, don't do it. If it happens, expire everything immediately, right? Do not keep them around. Expire those immediately as soon as you find out. I recommend looking at end files, .m files, so I have links to that. If you use Ansible, you could use Ansible Vault. That's a good way as well. So that was it. InfoSec is a mindset. It is our collective responsibility from executives, managers, software engineers. Try to subscribe to InfoSec mailing list. Here are the few that I subscribe to. There are actually a few more that I do subscribe to. And when someone does get owned, do not laugh at them. Remember that this could be us. Do whatever you can to understand how they got owned and see if it's applicable to us. And that's all I have about all that. Here are slides again, and Twitter. Feel free to say hi, and I'll be available for questions.
Wonderful. Thank you so much, Chris. We don't have time to actually pop into the Zoom room to do questions there, but just to kind of one quick question from just a general perspective. If somebody is kind of overwhelmed and just getting started with all this, and they just need that one place to go, what's the one place that you would send them to kind of just get started into the InfoSec world, or making sure their app's a little bit more secure?
oauth.org.
Awesome. That's like the de facto place, huh? Wonderful.
Yeah,
awesome.
Really,
thank you so much again.
That's why I reference them a lot. It can be overwhelming to jump into OWASP, and so this kind of helps. This presentation kind of helps as a way to guide yourself to it. So,
absolutely. Oh, we actually do have another question. I believe we're going to pull it in from Zoom, right? The question. We might do a little switch here.
Hello, Chris. So
hey.
I have a question about the using emails for login. So
Yes.
recently, well, previously, as I remember, everyone was using the separate login and separate email, but now they're using email for login. How do you feel about this practice? Is it secure, or are there any things that could go wrong?
Right. So that you're saying like every time somebody logs in, they get sent an email with like a token. They just kind of click on it to log in every time. Is that what you're saying? Right. So you click your password. Yeah, I've seen this done in applications where you don't want to. You don't want to make users create passwords and store passwords, and you want to force them to always go through their email to log in. It puts a lot of responsibility on your email, and email accounts do get cracked. I haven't seen that done too much. I'm not a fan of it, kind of from a usability standpoint, and from a security posture standpoint, I'm not sure really. Like if my email gets compromised, somebody can see my account, to my account, and they can see that I'm always using this website, and now I can go to that website without knowing about it. I mean, if my email does get compromised, somebody might eventually see that right now, the current way of doing things, they need to know that I'm a member of this site, and they need to have access to my email, right? If people do what you just mentioned, as soon as somebody compromises my account, they're going to know almost right away that I'm a member of this site, and then I can just kind of click to log in. So. Yeah, not a big fan of it.
Thanks so much, Chris. One last question. Do you have any recommendations on specific places that we could use better random numbers. And I'm sorry if this is a little duplication from earlier that you mentioned in your talk. I was doing some administrative things, but just sort of like specific places where we might want to make sure that we're not using like insecure random numbers or like with empty rand or something like that. Always kind of keeping that in the back of the head, back of the mind.
Oh, yeah. Actually, I have not looked into that myself.
Okay.
But yeah, you're talking like, yeah. I don't much use random numbers in applications yet. But yeah, I could see how that could be a problem. I'd have to research that.
Yeah, no worries. Is there anything in particular, like in your experience, where like you experience one particular problem more than another, and you're like, wow, this one just appears all the time for every application?
Yeah. SQL injection to me has been like a big thing. I've come across that a lot in the past, as well as the last thing that I mentioned, which is broken access controls. Where again, you have an ID, a resource ID in the URL, and you just kind of increment it and decrement it, right? And then you can see other users, and these things get overlooked all the time.
Right.
Yeah.
I've definitely been bitten by that one as well. Like,
yeah.
Absolutely. Thanks again, Chris, so much. If you'd like to join Chris in the Q&A room, join the Zoom link that you can see in the chat.
So we're waiting for Chris to join us. If you have any questions, please raise your hand, or you can ask your question in chat. We try to read everything what we find. So looks like Chris have some difficulties to join us. I see him in chat already.
Here we go. Cool.
Yeah. Hey, Chris.
How's it going?
Thank you for a great talk. It was a really good guide, security guide for web applications. So I have questions from me, and also we already have few in chat. I'm personally interested in second factor authentication. You said that phone validation or SMS is not truly safe. Could you recommend something which we can use for second factor?
Yes, and I should have mentioned that. So, there are authenticator applications, right? You have the Google Authenticator app. Yeah, I wish I had brought this up in the presentation, but yeah, the Google Authenticator app is used by several applications out there, including GitHub, right, where you can get your verification codes in there. So it's like you create a GitHub account, and then when you set up a multi-factor, they give you a QR code, and you put your phone to it, and then it will sign you up in the, it will link the account on your authenticator application. So that's one. And then the other one are the YubiKeys. That's another thing I should have mentioned. Yeah, so YubiKeys, YUBKEY. There are encryption keys that there are physical hardware that you can put on in a device to validate your authentication. Yeah, here, let me put the link to YubiKey on Wikipedia. Just hold on. I'm going to put it in the chat window.
It's little bit expensive to have a hardware device for each user. For example, social network.
Yeah. Yeah, no, it's definitely not for everyone, right? And there are different layers, right? It kind of depends, who you are and what you do, right? But yeah.
It's for some sensitive processes and sensitive information.
Yeah. However, there's also another standard, and I've been meaning to mention that in my talk as well, but hold on. I'm putting a link in the chat room as well to Google Authenticator. That's one of them. And then there's I forgot the name of it. What is it? I think it was WebAuthn. Yeah, I think it was WebAuthn.
Okay.
So yeah, so I'm putting a link to WebAuthn as well in the chat, because this is like an emerging thing that could allow us to not have to use passwords anymore.
Okay, thank you, Chris. So let's read questions from the chat. Question from Dasha. Is there a way to intercept the oauth token and use it from another device? Is it possible?
Say that again, sorry, the audio cut out.
Is there any way to intercept the oauth token and use it on another device?
To intercept the oauth token and use it in another device?
Yeah.
Not if you do it well. So if you're using, an OIDC provider that has been well vetted, whether it's an open source library or it's in like a third-party service like Okta, and you are using their APIs and SDKs as they were intended, then it should be secure, and then you should not be able to intercept a token if you're not supposed to have it. If you could use it if it's like your token and you want to try to use it on a separate device, as long as it is your token, right? Like you look at it, you might be able to do it. That might work. But again, it's not a security circumvention. It's you kind of trying to do something else with what you have, right? And I just don't recommend it. I haven't tested that. But otherwise, from a pure security standpoint, it should not be possible for one user to intercept a token of another user, for example, and try to use it on some other device.
Okay. Chris, did you take a look into enterprise static analysis for PHP, or do you find it good? If so.
Yeah. So the only one I've been using is SonarQube's Sonar PHP plugin, and so far it's been pretty good. So the SonarQube PHP plugin will give you static analysis from both a code quality standpoint as well as security. It does both, and it does have a lot of noise, like things where you're like, like for example, every time if you use the word password in a variable in your code, it assumes that you have a vulnerability in there. And so it'll flag it, right? And I'm like, well, no, I don't like that, right? So you can override it. You can put like an @no sonar annotation in front of your code. It kind of sucks. That's one of the more objectionable rules I've seen. Otherwise, most everything that it flags is pretty relevant. I've been using it on a like really old code base, and so it flags so much, right? But the security, that's from a quality standpoint. From the security standpoint, everything that it flagged was actually fair. Like some of the ones that it flagged, I was like, oh, come on. And I looked at it, I was like, oh yeah, okay. That could be an issue. So yeah, we managed to get to 0 vulnerabilities as flagged by Sonar static analysis. So.
Okay, thank you. The next question is, what if Microsoft Excel reports requires access to database, and in such situation we can't keep database closed from open networks? How to secure database at this point?
It depends on what your database is. So all databases support the ability to have a username and password. Definitely do that. But then try to not have. So first off, only give the permissions that are absolutely necessary, right? Does your Excel spreadsheet need to change the database? If not, at least just make it a read user, right? That's one layer. And then the other thing you can do with all databases is you can restrict which tables a user can see, right? You can see this user is only able to see the following 3 tables, right? Boom, use that. Okay, and then try to make multiple users for multiple people. Is it practical? Is it practical to give a dedicated username and password to every single user who needs to access your database? If you need, for example, you could be in a corporate enterprise and you could have Active Directory, right? So Active Directory is a central way to manage users. I don't think there is an Active Directory integration with MySQL, but maybe you're using SQL Server. And there might be a SQL Server integration with Active Directory. Actually, I have not looked into it, but since it's a Microsoft product, maybe there is, right? I don't know. But if you have kind of centralized user management somewhere, can your database kind of interact with that such that you don't have to, give yet another username and password just to access the database, right? Because when you fire somebody or if they quit, you can just disable their account in Active Directory and then you can't touch, the database, right? So the least privilege principle is always a good thing to keep in mind, right? Can this person restrict as much as possible what a person can do and try to keep things as granular as possible. That's kind of how I would look at it.
Okay, thank you. And we have the last question. Chris, what is the best to configure the secure database? How do you configure the firewall?
So what you want to do is have the database and the web server on their own network, but try to have the database behind a firewall. So you are completely restricting which port the web server can talk to the database host on, right? So if your web server communicates with your database over 3306, make sure your web server can only talk to the database over port 3306. right? Because if somebody compromises your web server and they have SSH access, to the web server for some reason, they managed to compromise every layer of security above the web server, and they've managed to get a shell onto the web server. You don't want them to try to do low-level hacks on the database host. You only want to allow it to talk over port 3306. So that's what I would do. And then databases like MySQL, obviously make sure you set a username and password, right? And then databases like MySQL now, they support encryption certificates, such that it's not just a login and password. Now you also have to have an encryption certificate as well as part of the authentication scheme, right? So if that's available to the database that you're working with, definitely try to do that.
Okay, thank you, Chris, again. And the last, what I would ask you is to choose the best question.
Sorry, to choose the best what?
Question.
Oh, you want me to choose the best question?
Yeah.
Of all the questions that were asked just now?
Yes.
I think I forgot most of the questions. But yeah, I think this last one was good. Actually, you know what? The question about configuring Excel to talk directly to the database. Yeah, I hadn't thought of that. I thought that was a pretty fun thing to think through.
Okay. Thank you, Chris. And everyone, bye-bye.
All right. Thank you.